For detailed information on advanced machining processes, visit www.agstech.net. One of the techniques is called Electrical Discharge Machining, or EDM, is a non-traditional machining process. It is also known as spark machining, spark eroding, burning, die sinking, wire burning, or wire erosion. EDM is a thermal process that removes material from a workpiece by using electrical discharges, or sparks. EDM can machine complex shapes and cavities that would be difficult or impossible to create with traditional machining methods. It is widely used in industries such as aerospace, automotive, medical, and mold making. EDM works by creating a controlled electrical spark between an electrode and a workpiece. This process is known as Electrical Discharge Machining, or EDM for short. The electrode and workpiece are immersed in a dielectric fluid which acts as an insulator and a coolant. This fluid is crucial for maintaining the stability of the process. The electrode is typically made of a conductive material such as copper, graphite, or brass. Each material has its own advantages depending on the specific application. When a high voltage is applied between the electrode and the workpiece, an electrical discharge occurs across the small gap between them. This discharge is precisely controlled to achieve the desired machining effect. This discharge generates intense heat, reaching temperatures of up to 12,000 degrees Celsius. The heat is so intense that it can melt and vaporize the material. The heat vaporizes the workpiece material, creating a small crater. This process is repeated thousands of times per second, gradually shaping the workpiece into the desired form. There are three main types of EDM: Sinker EDM, Wire EDM, and Fast Hole Drilling EDM. Each type has its unique applications and advantages. Sinker EDM uses a shaped electrode to create complex cavities in the workpiece. This process is highly precise and can produce intricate details. This type of EDM is commonly used to make molds and dies, especially for the plastic injection molding industry. Wire EDM uses a thin wire electrode to cut through the workpiece. It is known for its ability to cut very hard materials with high precision. This is ideal for creating intricate shapes and profiles, such as gears and complex metal parts. Fast hole drilling EDM, as the name suggests, is used to drill small, deep holes with high precision. This is particularly useful in industries requiring fine, detailed work. EDM is used in a wide range of applications, from simple to highly complex parts. In the aerospace industry, it is used to machine complex parts for jet engines and turbines, ensuring high performance and reliability. The medical industry utilizes EDM for creating surgical instruments and implants, which require extreme precision and quality. In the automotive industry, EDM makes molds for various parts and components, contributing to the production of high-quality vehicles. EDM, or electrical discharge machining, offers several advantages over traditional machining methods. It can machine very hard materials, including hardened steel, which is often difficult to process using conventional techniques. Materials like carbide and titanium, known for their toughness, can also be effectively machined using EDM. EDM is a non-contact process, meaning it does not exert cutting forces on the workpiece, reducing the risk of damage. This makes it particularly suitable for machining delicate or fragile parts that might be damaged by traditional methods. EDM can produce extremely accurate and intricate shapes, allowing for high precision in complex designs. However, despite these advantages, EDM also has some notable disadvantages. One major drawback is that it is a relatively slow machining process, which can be a limitation in high-volume production. Additionally, EDM can produce a heat-affected zone on the workpiece, which may require further processing to remove. The initial investment cost of EDM machines is high compared to traditional machines, making it a significant financial commitment. For more information on the latest advancements in EDM and other machining processes, please visit www.agstech.net. Stay updated with cutting-edge technology.